Hello guys, thank you for clicking on this video. Today I'm going to go over IPv4 and IPv6 in talk about IP addressing. This will be a brief overview of what IPv4 and V6 is. Okay, so let's start with the term IP addressing. So IP addressing is an internet protocol address. Well, IP address stands for internet protocol address. This is a logical numeric address, that is assigned to every single computer, printer, router, switch, any other device that's part of the TCP/IP based network. IP addressing is the core component that is used to build a network. No network is built without it. IP addresses uniquely identifies any node on the network, and since IP addresses are logical, it can be changed. They can be changed. So IP address IPv4. This was defined in RFC. I forgot what it stands for. This was defined in RFC 791 in 1981, and then the IPv4 space is owned by Internet Assigned Numbers Authority, which you must have seen the acronym. You must have seen the acronym in a lot of places like AIANA. And IP addresses are made up of 32 bits. And when IPv4 was first created, there were 4.2 billion addresses. But now, they've grown, so that's why we have IPv6 now soon, because public address pools is exhausted soon, and I'm going to talk about that in a second soon. What is the work around it? So the IPv4 structure is like you see over here. There's always 4 numbers over here, like you see. They're written in base 10. IP address v4 will always be 4 numbers, like what you see here on the screen, separated by dots. Computers use binary, not decimal, so the above is how computers will deal with IP addresses. In IP addresses, you have 2 different identifiers. So the first 3 bits over here are what is known as the network ID that you're currently on, and the second bit, which is this bit over here, in this instance, would be the host ID. Every number in an IP address is 8 bits, okay, or 1 byte or 1 octet. So this will be 1 octet over here, 1 byte. So 4 different numbers in an IP address brings us to a total of 32 bits or 4 bytes. If you calculate the max decimal value we can reach in binary, having 32 bits, you'll reach 255. So the max number in each octet of IP address says cannot exceed 255 in decimal format. The second item which is required for TCP/IP to work is a subnet mask. Okay, so so subnet mask is used to determine whether or not a host is on a local subnet remote network and remote network. Subnet is short for subnetwork, but most of the times you only see subnetwork. It referred to as subnetwork. In TCP/IP, the parts of IP addresses used for network and host addresses are not fixed. So subnet mask is used to, hold on. Subnet mask is a 32-bit number. And let me just see if I can find a subnet mask. Subnet mask. This will be the subnet mask over here. In another video, I'm going to go into more details about IP addressing and working out subnet masks and how to work out, convert to binary and all that stuff. But for now, I'm just going to give you a brief overview. So then that brings us to the different IPv4 network classes. So class A, the first octet, I'm saying, if it's between 1 to 126, it'll have a subnet mask, default subnet mask of 255.0.0.0. Okay, that'll be classed as a class A, IP address, IPv4 address. Class B is any first octet that you see which is between 128 to 191, has a subnet mask, default subnet mask of 255.255.0.0. That'll be class B. Class C is 192 to 223, and the default subnet mask for that would be 255.255.255.0. Then there's D and E as well. I'll go over that in a second here. So a class A, B, or C network can further be divided or subnetted by a systems admin. Classless inter-domain routing is a way to allow more flexible allocation of IP addresses than was possible with the original system of IP address classes. You can also break your network at any bit boundary. So you could have, for example, 192.168.0.0 par 19, giving you a subnet mask of 255.255.224.225.224.0, which would allow you to build 8 subnets with 190 hosts per subnet. Then you have private IP addresses. These are mostly used internally. Saying within an organization, they'll have a NAT, which is network address translation, which basically translates IP address. It gives a private IP address to internal machines, and before, when your computer sends a request to communicate with the internet, it converts it into an actual IP address. You know what I'm saying? And again, I'll go into that in more detail afterwards, in another video. So right now I'm just going to go over our private IP addresses. So 24-bit blocks. Let me just pull up a table and see if they've got any private IP address. Yeah, as you can see on the screen, this is a table for private IP addresses, different ranges. Okay. So a network address translation NAT on the router will remap translate to public IP address as we go onto the internet. And then we have IPv6. So IPv6 is 128 bits, and it has this many undecilin, I hope I pronounced that right, possible addresses. It's represented in hexadecimal, so there's, like you see over here, numbers and alphabets, and it coexists with IPv4. Okay, so this was just a short overview of IP addresses V4, IP address V4 and V6. I'm going to go into more details in another video, like I said. and I'll explain everything in more detail. Hopefully it makes sense, and hopefully I've just touched on it just to you know uh, get you interested in learning more about this. Um, Thank you for watching again, and thank you for your continued support. Thank you. Bye.